Hello everyone. Today we are going to discuss the chapter 1 of class 10 science, that is chemical reactions and equations. In this chapter, first of all we will understand about what is a chemical reaction. As you know, a chemical reaction is a process in which any two substances, when they combine together, they produce a new compound or a new substance. And the representation of such a reaction by using some symbolic representations of the and by some chemical formulae is called as a chemical equation. In this chapter, we are going to discuss in detail about various types of chemical reactions, how are they represented, and how to balance the chemical equation, and along with a lot of examples associating with it. So let's get started. The first topic of our chapter will be describing a chemical reactions, and in here we will see how what are the various indications of a chemical reactions. When any evolution of heat, light or sound is produced, then we can say that a chemical reaction has taken place. Production of or evolution of any gas, if it is produced, then it is a chemical reaction. Formation of a precipitate means deposition of a solid is also an indication of a chemical reaction. Color change is also a very important phenomenon that tells us that a chemical reaction has taken place. So in that way, we can say that different observations and different signs are given which tells us that chemical reaction has taken place. That is change in color, change in odor, production of new gas or vapors, input or release of energy that we will understand as endothermic and exothermic reactions, and which most of the chemical reactions are difficult to reverse. It is just like it is very difficult to reverse the aging process. So these are the various signs, or we can say that a chemical reaction has actually taken place. Generally, we use a kind of representation to show any chemical reaction, and that is called as a chemical equation. So in a chemical equation, there are two very important components. One is reactants and another is products. For example, let us take the example of aluminium and oxygen, which gives rise to a compound called as aluminium oxide. In this, aluminium and oxygen are called as the reactants, whereas aluminium oxide is called as the product. In any of the chemical equations, we generally use some letter symbols like S, G, and L. There are several other symbols also. We will talk about that in coming up topics. S represents solids, G represents gas, and L represents liquids. They denote the physical states of the compounds or the elements or the molecules which are going into the chemical reactions. And also at the same time, we will see that in front of these elements like aluminium, like oxygen and aluminium oxide, we have also put some numerical values, and these numeral values are called as stoichiometric coefficients. Whenever chemical reaction like this is written, when aluminium is reacting with oxygen to give aluminium oxide, what does this reaction actually mean? Does it mean that 4 grams of aluminium reacts with 3 grams of oxygen to give 2 grams of aluminium oxide? Or else, what does that mean? It is actually a wrong meaning out of it. This equation actually means that 4 aluminium atoms, they react with 3 oxygen molecules and they yield 2 molecules of aluminium oxide. But then we have also understood in class 9 that a chemical reaction always shows conservation of mass. So in terms of mass, we can also say that 4 moles of aluminium reacts with 3 moles of oxygen and 2 moles of aluminium oxide are yielded. So in that terms, the mass of aluminium and oxygen and aluminium oxide is also taken into consideration, in which if we calculate, we say that law of conservation of mass is very well represented. Chemical equations. Because same atoms are present in a reaction at the beginning and at the end of the chemical reaction, the amount of matter in a system does not change. Means in the chemical equation, we will also find that there is a kind of law of conservation of matter. So if we say that 100% of these reactants are going into the chemical reaction, then at the end of the chemical reaction, again 100% of these atoms of the reactants will be obtained. But it may be possible that 80% or 20% or like that, the distribution of the atoms in the products may also happen. But that does not mean that law of conservation of matter is not followed. Chemical equations also and every time does follow the principle of conservation of matter. At the same time, a chemical equation must be also balanced. What does that mean? It must have the same number of atoms of the same kind of and on the both sides. So, when we say that, what are the characteristics of a chemical equation? The equation must represent known facts. Actually, what happens? Many times we say that a chemical reaction can be written on its own as we want to, but it does not happen like that. What happens is we have to write down the chemical equation if it is actually happening in reality. For example, if I write iron sulfate which reacts with copper and it forms copper sulfate plus iron. So this reaction does actually seem to be very correct, but at the same time this reaction does not take place because copper is less reactive than iron, and this copper cannot replace iron from its salt solution. Rather, the reaction will be the other way round, where iron actually displaces copper from its salt solution, and thus even if this reaction, the previous reaction does seem very clear or happening, but it is not the actual way. So that is why the equation must represent known facts. At the same time, equation must contain the correct formulae of the reactants and the products. So whenever we write down the chemical formula of any kind of compound, the chemical formula should be the correct one. Like if we say that sodium oxide, it can be represented, if someone writes these formulae of sodium oxide, but out of these they all containing sodium and oxygen in all the three cases, but actually the correct formula of it is sodium oxide. If for any matter NaO or NaO2 is written for the sodium oxide, this will create a wrong impression and the equation will never be correct and it cannot be balanced ever. The third characteristic is the law of conservation of mass must be satisfied. So as I've told you that whenever a chemical equation is written or chemical reaction takes place, it always follows the law of conservation of matter and law of conservation of mass. In a chemical equations, the reactants are the most important components. These are the substances that exist before a chemical change has actually taken place. Products, the new substances that are formed during the chemical change are called as the products, and chemical equation indicates the reactants and products of a reactant. So whenever a reaction is going on, reactants gives rise to the products, and ever the products are not equal or same as that of the reactants or vice versa. In the beginning, word equations are the simplest way to represent any chemical change, and in which the names of the reactants and products are used. Just like if we say that methane reacts with oxygen. Now, methane is a chemical whose chemical formula is CH4, but writing methane, it is a kind of word equation, and when methane and oxygen it reacts, they actually give you carbon dioxide and water. So this is a kind of reaction which is called as the word equation, but at the same time these are gradually replaced by the symbolic representations of CH4 for methane, O2 for oxygen, which gives rise to carbon dioxide, and H2O, that is for water and carbon dioxide. So once the reactions are written, the next process is to balance it. So whenever a chemical equation is written in the symbolic form, we have to see that the number of reactants and the number of atoms on the reactant side and the product side is always same. So in that way, we have to put the coefficient in front of the unbalanced elements or atoms of the elements. For that, here you can say that oxygen was not balanced and hydrogen was also not balanced. So previously we have put 2 in front of oxygen and water both. What is an unbalanced and balanced chemical equation? As the picture shows here, it clearly represents an unbalanced chemical equation wherein 2 hydrogen atoms and 2 chlorine atoms are there onto the left hand side, whereas on the right hand side what we observe is only 1 hydrogen and 1 chlorine atom is represented. This chemical equation can be also written as when hydrogen molecule it reacts with chlorine molecule, it gives rise to hydrogen chloride. So this chemical equation is actually an unbalanced one. And for unbalanced one chemical equation, how to represent that? Reactants. If we have to balance the chemical equation, we have to know how many atoms of what atom of which element have to be balanced, and for that we have to make a kind of checker box in which we can easily write them the components of the reaction. Hydrogen and chlorine in this matter are the components. So hydrogen on the reactant side, there is 2 atoms of hydrogen and 2 atoms of chlorine, whereas on the product side there is only 1 atom of hydrogen and 1 atom of chlorine. So this is called as an unbalanced chemical equation, but when it has to be balanced, we say that there are 2 atoms of hydrogen, 2 atoms of chlorine on the reactant side, 2 atoms of hydrogen and 2 atoms of chlorine on the product side as well. How does that happen? Whenever a chemical reaction is taking place, it actually takes place by equal distribution of the atoms present going into the reaction. Such as if sodium and chlorine has to react, it will form sodium chloride. But for that you can say that sodium, if 10 moles of sodium are taken and 5 moles of chlorine are taken, then how many moles of sodium chloride will be formed? Just have a look here. Sodium and chlorine, they react like so. In sodium chloride, only 1 atom of sodium and 1 atom of chlorine are present. So how does that happen? 1 atom of sodium, it is going with 1 atom of chlorine, and in this way all the sodium and all the chlorine atoms will be binding with each other. So as you can see that each sodium atom is binding with individual chlorine atoms. And finally, after the completion, we find there are 10 moles of sodium chloride which are obtained. So this 10 moles of sodium chloride represents that it is not that the 10 moles of sodium when reacted with 5 moles of chlorine will form 15 moles of sodium chloride. Rather, they actually form 10 moles of sodium chloride. Whenever a chemical formula is written, it has got a meaning to it. Like if we write chemical symbol of water is H2O, it means that one molecule of water and its composition is 2 atoms of hydrogen and 1 atom of oxygen. In the similar way, if we write 2H2O, it means 2 molecules of water and in which 2 atoms of oxygen and 4 atoms of hydrogen are present. Now let us understand about the balancing of chemical equation. What is a balanced chemical equation? Balanced chemical equation is one in which the number of the atoms of each element as a reactant is equal to the number of atoms of that element as a product. So it means that atoms of the elements on the reactant side and on the product side should be always same. Like if in this reaction 2Na plus H2O, it gives rise to 2NaOH plus H2. In this chemical reaction, you will find that the number of sodium atoms on the reactant side, they are equal from on the product side. The number of hydrogen atoms on the reactant side, are they equal on the product side? They are not equal on the product side. Number of oxygen atoms on the reactant side, are they equal on to the product side? Again, they are not equal. So this is a kind of unbalanced chemical equation. So to balance it, we have to put this stoichiometric coefficient, that is 2, in front of H2O. And once we put this numerical value 2 in front of hydrogen, in front of water molecule, we find that the number of atoms of each component in the chemical reaction, they are same on both the sides. So thus we can say that it is a balanced chemical equation. Whenever we whenever we do the balancing of chemical equations, we have to first of all write a word equation for the reaction. And once we write the word equation, we have to take care that the correct formula of all the reactants and products are done. Then we have to determine the coefficients that make the equation balance. Let's have some more examples. Here, nitrogen monoxide, that is NO, is reacting with oxygen to form nitrogen dioxide. All the three are in their gaseous states. But is this equation balanced? No. As we can say that number of nitrogen atoms on both the sides are same, but oxygen is not balanced. So how can we do this balancing? If we put half atom of oxygen in this particular reaction, then it will be a kind of balance. But is this correct way of balancing? We have to put a kind of complete numeral value to balance a chemical equation. So that is how, if we put a numeral value of 2 on both the sides in front of nitrogen monoxide in the reactant side and in front of nitrogen dioxide onto the product side, then we can find that this equation becomes a balanced one. And the 2 to the left of nitrogen monoxide and nitrogen dioxide refers to the number of molecules present in the balanced chemical equation. And this numeral value 2 is a multiplier for every atom in the molecule. Here, a chemical equation is given where ammonium phosphate is reacting with magnesium hydroxide. So to give magnesium phosphate, and what will be the compound coming over here? It will be ammonium hydroxide. But how does it happen? Because ammonium phosphate and magnesium hydroxide is there, magnesium will be replacing this phosphate and from the ammonium, and ammonium will be replaced by hydroxide. So ammonium hydroxide will be formed over here. Let's find out this particular chemical equation, and it's a task for you to balance these chemical equations, and we will meet in the next class for the next topic, that is chemical equations and reactions, in which we will try more balancing of chemical equations, more examples of that. Until that time, revise this chapter or the topic carefully.